Now that we've been studying derivatives in quite a bit of detail, we are going to just get our feet wet into something that's called antiderivatives. At the end of this lesson, you'll be able to find the antiderivative of a function. Okay, using a given derivative, you will be asked to find a function that has that particular derivative. So if I said my derivative is, let's say my derivative is x, we'll call it 3x squared. Okay, what I'd be looking for is, so I'm given a derivative, I am looking for the function that when I take the derivative of this, take the derivative of the function, I would get 3x squared. So you could think about it. I know that if I had if I had x to the third, if I took the derivative of x to the third, it is 3x squared. So this right here would be called the antiderivative. Okay, notice that wouldn't be the only antiderivative, because what if I put y equals x cubed plus 6? Notice if I took the derivative of this, I'd also get 3x squared. So there can be more than one antiderivative. I might have y equals x cubed minus 7. Again, if I took the derivative of this, I would get 3x squared. So there are actually lots and lots and lots of different antiderivatives. And what we will do, because there are so many antiderivatives, it's always, we can add a constant or subtract a constant. So I actually am going to rewrite this. My true antiderivative would be y equals x cubed plus c, because c is just going to stand for some constant. So it doesn't matter what I put there, when I take the derivative of it, it will drop out. Okay, we're going to use that information to try to solve an example. This example says to find the function f of x whose derivative is sine x and whose graph passes through the point 0, 2. So we're going to be looking for a specific antiderivative. So first of all, we're looking for a function whose derivative is sine of x. So what function would I start with? So it says to find the function f of x. What function would I start with so that when I take the derivative of it, I get sine x? So that's f prime. Okay, so my function would actually be, if my function were cosine of x, the derivative would be negative sine x. I only want to get sine x, so I'd have to start with negative cosine x. Okay, so I have f of x is equal to negative cosine x plus c, because again, this could be any constant, and when I take the derivative of it, I will get sine x. Now, what we want to do, my specific antiderivative, or my function, I want it to pass through the point 0, 2. So just how we do for equations of tangent lines, I'm going to plug in 0 and 2 for what I know. So 2 is a y value, which is the f of x. So I'm going to put 2 equals negative cosine, my x value is 0, plus c. And so now from here, the cosine of 0, it's not the inverse cosine of 0, it's just at 0. So at 0, what is my x value? And my x value there is 1, so I'm going to have 2 equals negative 1 plus c. Solving for c, I get c is equal to 3. So instead of having to put plus c in this, my specific function is going to be f of x equals negative cosine x plus 3. Okay, and again, we're going to get into this quite a bit more in our next chapter. This was, again, just getting your feet wet a little bit for what we're going to be studying next. Oh, all right, and we have another one, I guess. All right, antiderivative, a function f of x is an antiderivative if f prime of x is equal to the function for all x in the domain of f. This process is called antidifferentiation, and we just did that, so that was just formally saying what we did. Okay, number 6 says to find the velocity and position of a falling body falling freely from a height of 0 meters if the acceleration is 9.8 meters per second squared and the body is propelled downward with an initial velocity of 1 meter per second. So we're looking for the velocity and we're looking for the position, and they told me what the acceleration is. So I'm just going to put the acceleration is equal to 9.8. All right, we first of all want to know that velocity. Well, we know that acceleration is, when I take the derivative of velocity, I'll get acceleration. So what does my velocity have to be so that when I take the derivative of it, I'll get 9.8? And it would have to be 9.8 x, or 9.8, I'm going to say t. So notice if I take the derivative of 9.8 t, I will get 9.8. But remember, we're always going to put, it could have been plus some constant there. Okay, so now what we are going to do is try to find what that constant was, because they gave us a lot of information. And did they give us anything about the velocity? Yes, they did. They said the initial velocity was 1 meter per second. So that means at time equal 1, at time equals 0, the velocity was 1. So now I'm just going to plug that information in. I'm going to get 1 equals 9.8 times 0 plus c. Those will be 0, so I'll just get c is equal to 1. So my velocity now is 9.8 t plus 1. All right, so I found the velocity. Good for me. Okay, the next one is going to be to find the position. We could call it p equals. I'm going to call it s equals because that's what we usually do. And again, what we're doing, whatever I write here, when I take the derivative of it, I need to get 9.8 t plus 1. Okay, so I am going to write, if I wrote 4.9 t squared, notice when I take the derivative of that, I'm going to get 9.8 t. And then plus, what would I have to write to get a derivative of 1? I would put plus t, and then once again, we know there could be a constant, and when I take the derivative of it, it would drop out. So I am going to put a new plus c there. All right, and once again, they gave me information, so I can actually find that. They tell me this was a position, so they told me it's falling freely from a height of 0 meters. So that means at time equals 0, the position is 0. It's just on the ground. So the position is 0 at time 0. Those will all be 0, so we see that c equals 0. So my position formula is 4.9 t squared plus t and then plus 0. So I found the position and I found the velocity, and again we can just double check. If I take the velocity, if I take the derivative of position, I do get to velocity, and if I take derivative of velocity, I do get to that acceleration. So everything worked out. So hopefully now you're somewhat familiar with finding the antiderivative of a function.